Hey, what's going on, guys? Let's do this problem right here. This question is asking a current of 1.25 ampere passes through a solution of CuSO4 for 39 minutes. Calculate the mass of copper that was deposited on the cathode. So when copper is deposited on the cathode, the reaction is going to look like this. Cu2 plus 2E, that gives us Cu, right? So this is the equation we are going to use. Now to calculate this mass is the question, right? Calculate the mass of the copper. We need two external information. That is, one of them is Faraday's constant. That's going to be 96485 coulomb. And then also we need the molar mass of copper. That is, so let's say capital M Cu. That's going to be equivalent to 63.55 gram per mole. Now let's see how we can calculate this one. So the given information are current, that is 1.425 ampere. So we have current, that is 1.25 ampere, and we have the time, that is 39 minutes. So here we have to convert this one into second, because we are going to use this equation. Q is equal to IT. First of all, we have to calculate the charge. Right? To calculate the charge, we use this equation. Then we use Faraday's constant and molar mass to convert this one into mass. Now let's look at the time first. We have to convert this one into seconds. So we have 39 minutes. To convert 39 minutes, we have to multiply by 60 because each minute has 60 seconds. So we have to multiply this one by 60. And yeah, that's it. And let's plug the equations. Now let's say m of Cu is going to be equivalent to 39 minutes times 60, right? Maybe I keep the units also. So 39 minutes, in 1 minute we have 60 seconds, so 60 seconds over 1 minute, and then we have 1.25 ampere. So here ampere is also equivalent to coulombs per second. So you can write this one coulomb per second, because if you write in that way, it's easy to see the units cancelling each other, right? So now I'm going to write coulombs per second. Now this is 1.25 coulombs per second, right? 1.25 coulombs per second. You can already see this minutes cancels, and this, if you multiply second and this second cancels, but we have this coulomb. So here we know that the Faraday's constant is there. That is, in 1 moles we have this many coulombs, 96485. So this is actually, Faraday's constant is actually coulomb per 1 mole of electron. So that's what it represents, right? So this one is going to be 96485 mole, coulombs per mole. So this will be coulombs. And then we have molar mass of copper. So in copper we have, in 1 mole we have 63.55 gram per 1 mole, right? And also we have 2 moles of electron, right? So we have to multiply this one by 2 moles. So this is going to be 1 mole. In 1 mole we have 2 moles of electron. So maybe I write the electron here too, because that way we can see that one also cancel, right? Now let's cancel whatever we can cancel. Now first, if I start with minutes cancels, this second cancels, and this coulomb cancels, and here we have 1 mole of electron in the top, and we have 1 mole of electron in the bottom, right? And then we have gram, okay, this is gram per mole, and we have to get rid of this mole too, and we have this 1 mole right here. So 1 mole cancels, and we are left with this value. So there's a, whenever we have this kind of situation, if you have confused about putting this one, like whether to put this one on top or bottom, the conversion factor is two-way possible. Like you can always write 1 over this, like for example this 60 second per minute, you can write it as 60 second per minutes, or 1 minutes over 60 second. So the conversion factor is going to change, but we have to look at the answers we are trying to get. That's the main thing, right? We have to try to cancel each other, and in this case we are trying to get gram, right? Gram has to be on top, so we have to arrange this one accordingly. So it happens in case like we have to use this technique in case if we forget the equation, right? Now we have put everything correct. Now all we have to do is find the final answer. If you multiply everything together, this is going to give you 0.963 gram, and that's going to be our final answer. I hope you guys find this video helpful. See you next time.